As far as the top, well, I've got a few things I got to do. I got to do 2 minus 5, which would give me negative 3. And then I got to add in the 9, and negative 3 plus 9 is 6. 6 11s. Okay. One more common denominator, then we'll get to the real tricky stuff with different denominators. The next problem, 27 1/4 minus 14 3/4. So you're saying, oh man, I got to change this improper, then subtract, this, that. Not necessarily. In this problem, since they're the same sign, you can get away with one thing that we didn't do earlier because those have different signs than other times. But since these are the same sign, you can get away with something here. What you want to do in these problems is subtract the various parts. What I mean is start with the whole number parts, so 27 and 14. Okay? You know 27 minus 14. 27 minus 14 is? 13. Then you want to subtract the fraction parts. Now, when you do that, you've got 1/4 minus 3/4. Realize we're subtracting because that's what's going to go. I do 1/4 minus 3/4, and that's going to give me
2/4, 1/2.
Negative 2/4. You could say negative 1/2. Now, you're looking at the going, well, that can't be. Now realize the negative, which is on the half, looks like a subtraction sign. All right? So now we're just going to subtract. 13 minus 1/2. Well, you know that. 13, take away 1/2, you still got 12 and 1/2 left. And there's your answer. We didn't have to play around with getting impropers because they're the same sign. If it's a different sign, you can't get away with that trick. But if they're the same, you can. Okay.
I don't know.
Now let's work with different denominators. This will be the harder part of the thing. Remember, when you have different denominators, you have to start off by getting common denominators. So if we take a look at the first problem, we've got 7/8 and negative 2/5. Now, again, I said earlier, you have to use the least common multiple to get the same denominators. So remember, there's two ways you can do that. You can do that with a factor tree, or you can list multiples. Now, I'm going to list multiples on the first couple, and then after that, I'm going to leave it to you to pick whichever way you want to do it. So here, my denominators are 8 and 5. Well, if I list the multiples of 8, I would have 8, 16, 24, 32, 40, 48. For 5, I would have 5, 10, 15, 20, 25, 30, 35, and 40. Aha! We got a match in 40. So that means my common denominator is going to be 40. Now, I have to figure out how I changed 8 into 40. And when I say how you did that, I mean in terms of multiplying. Well, I multiplied by 5, of course. 8 times 5 is 40. Since I multiplied 8 by 5, I have to multiply 7 by 5 as well. And of course, that would get you 35. Now, over here to change 5 into 40, I would have had to multiply by 8. So I'm going to multiply the 2 by 8 as well. And 2 times 8 is 16. And it needs to stay negative. So, now I've got common denominators. Now I can do exactly what I was doing over there. 35 plus negative 16. Well, 35 plus negative 16 gives me 19. You've got 1940s. Now, some of you say, well, do I really have to get the least common multiple? No, not necessarily. Some of you like to just multiply the two denominators together and say that's the denominator. Okay? You could do the problems that way. That's a choice that you have to make. All right. Personally, I like going the least common multiple because if I was forcing you to reduce, that would be a lot less work. But you don't have to do it that way. Okay? You can do it your way. Just make sure you're getting the right answer. Of course, it would be bubbled up larger, right? But you could still get the correct answer. Yes. 1/3 plus 3/8. 1/3 and 3/8. So start by listing multiples. 3, 6, 9, 12, 15, 18, 21, 24, 27. 8, got 8, 16, and 24. 24 is my common denominator. To get from 3 to 24, I would have had to multiply by 8. So I'm going to multiply